Hi everybody, hope that you're all doing well, that you're safe. We're now moving into Chapter 8 in the program, and Chapter 8 is specifically dealing with quadratic equations and the related quadratic function. So Chapter 8 is everything quadratic. And as we go to the board right here, we'll look at something that should be very, very familiar to you. We should know already from past learning that the standard form of every quadratic equation is ax squared plus bx plus c is equal to 0, where a, the coefficient of the quadratic term, b, the coefficient of the linear term, and c, the constant coefficient. A, b, and c are allowed to be any real number with one exception. A, the coefficient of the quadratic term, cannot be 0, because if it's allowed to be 0, then we won't have an x squared term, and we wouldn't have Chapter 8. But b and c are able to be 0, but a is not. Second item that we just want to mention from what we had looked at in the past, we've already solved quadratic equations by factoring. And we've already looked at, so to speak, an application of a quadratic function when we were looking at a word problem back in Chapter 5 that dealt with a Little League player throwing a ball up in the air and it then falling to the ground. The path that that ball took was the path of the primary graph that's going to be seen in Chapter 8. And you know it to be called a parabola. I don't think that's a new word to anybody that I'm talking to in this audience. And when we get to 8.3, we'll be dealing with the parabola and graphing quadratic functions. But not to get ahead of ourselves, in 8.1, we're looking at two other methods of solving quadratic equations. Because as you know, not all quadratic equations can be solved by factoring. Many of them cannot be solved by factoring, so we need other methods. And in 8.1, we're looking at a second method, the square root method, and a third method, completing the square. Now we're going to begin with the square root method first. And here's the premise statement behind the square root method. If we allow u, you can pick any other letter of the alphabet, but I'm going to pick u. If we let u be equal to an algebraic expression, and the variable d will be equal to any real number, and if this is the structure then of the equation that we're going to be looking at, and u squared is equal to d, definitely a quadratic equation because of the quadratic term here, and u squared is equal to d, the square root method then says we can take the square root of u squared, which would give us u, and u would be equal to either the positive square root of d, or u would be equal to the negative square root of d. Remember, when solving a quadratic equation, there are two solutions, always. So if u squared is equal to d, then u will be equal to the positive square root of d, or u would be equal to the negative square root of d. The premise behind the square root method is this format. And I'd like you to be aware of this format. Notice in this standard form right here, the linear term is missing. And here's the statement that we want to say. When you're looking at a quadratic equation that only contains the quadratic term and the constant term, but there is no linear term whatsoever in the equation, the square root method is the most ideal method to use to solve the equation. And so we're going to look at problem number 1 right here, and you'll notice on number 1, there is no linear term. We have a quadratic equation that says the perfect square, or the quadratic term, is equal to the real number 81. Now back in chapter 5, we could rewrite this in standard form and make it x squared minus 81 is equal to 0, and then factor that difference of two squares to get us an x plus 9 and an x minus 9, and that would lead to the two solutions, a positive or a negative 9. But we no longer have to make use of that strategy when we already have an equation that is pretty much written in the structured form that we saw outlined in that blue. When we see x squared is equal to 81, we'll simply go right to our solution. We bring down and find the square root of x squared, which is x. X will be equal to the positive square root of 81, or x will be equal to the negative radical of 81. And that will very nicely give us x is equal to 9 or negative 9, and we can write the solution as such. We can write them individually, the set whose members are 9 or negative 9, or you are able to write it in this form, and many do, a positive or a negative 9. Either one would be okay. That is a very elementary example of solving a quadratic equation using the square root method. Now let's just advance it just a little bit as we move to number 2. Number 2. 4x squared is equal to 48. We just kind of get rid of that, so if we need the room, we've got it. Now, as we take a look at number 2, we can certainly see the quadratic term on the left and the constant term on the right. But the quadratic term that's on the left can actually be simplified a bit to be able to get rid of this coefficient of 4 so that we'll just have the x squared. And to get rid of that 4, we'll divide both sides by 4. So if we take the left and divide it by 4 and the right and divide it by 4, we'll have perfect square is equal to real number 12. And now we'll go right into the square root method. X is equal to the positive radical of 12, or x would be equal to the negative radical of 12. Now the radical of 12 is not a perfect square, but the radicand of 12 can be simplified because 12 contains a perfect square factor of 4. So we're going to use the product rule of radicals and split this up. Then we'll get x is equal to the radical of 4 times the radical of 3. This one would be x is equal to the negative radical of 4 times the radical of 3. And when we simplify out of that radical of 4, we would get x is equal to 2 root 3, or x would be equal to negative 2 root 3. And for a lack of space, I'll just kind of leave the two answers written right in that format. One of the roots is 2 root 3, and the other solution is a negative 2 root 3. Now, as I go to problems 3, 4, and 5, I'm going to kind of condense a little bit further. I didn't do it on the first two, but I will on the remaining ones that we'll do. A little bit different, but still pretty straightforward. Let's go to number 3. We've got 3x squared minus 11 is equal to 0. Now we want to get it into the form where we have a perfect square, the most simplified perfect square on one side, and a constant term on the other. So we're going to need to move that 11 over to the other side, so we'll add it to both. And we'll have 3x squared is equal to 11. And now we'll get rid of that coefficient of 3 by dividing both sides by 3. And we'll get it down to x squared is equal to 11 over 3. Now people, I'm just going to kind of erase some information up here so I can kind of stay up here near the top. Let me just place where we stop right up here. X squared is equal to 11 thirds. Now from this point, I'm going to simplify the rest of the way by using sort of a shorthand approach like many of you will do. We'll find the square root of him and we get x. And that will be equal to positive or negative root 11 over 3. We cannot have a fraction in the radicand. So we're going to have to use the quotient rule of radicals and split this up. And so that will bring it down to x is equal to plus or minus the root of 11 over the root of 3. And now, looking at where we are right here, we cannot have a radical in the denominator position, so we're going to have to rationalize that denominator. We're obviously dealing with square root. I have one factor of 3 here. We'll need another one. So I'm just going to put a times sign right here, bring out the bar, and we're going to multiply both top and bottom by another radical of 3, so we can rationalize that denominator. And that will then get it down to x is equal to positive or negative root 33, those two radicals get multiplied, over the radical of 9. And now 9 represents a rational number, so our answer will be x is equal to positive or negative root 33 over the root of 9, which is 3, and it is done. It is not necessary to separate these into two different solutions. We can leave it stated in that way, and it's fine. So a little bit more information that needed to be done, following rules of radicals. That being number 3. Let's move to 4. And 4x squared plus 9 is equal to 0. Well, we've got to move that 9 over. So we'll have 4x squared is equal to a negative 9. And now let's get rid of that coefficient of 4 by dividing both sides by 4. And we'll have this down then to x squared is equal to a negative 9/4. Now, only because of our brand new numbering system that we looked at in the very last section of chapter 7, where we defined the set of complex numbers, they were defined for the very reason of what you're looking at right up here. X squared is equal to the real number of negative 9/4. And now it doesn't make any difference if the real number is negative, because we have the availability of the imaginary unit I. And so now we'll come down methodically and we'll write x squared is equal to, well, let's back it up. And let's go ahead and find the square root of this. That'll give us x is equal to plus or minus the root of a negative 9/4. Then that will give us this. X is equal to positive or negative root 9/4 times root negative 1. If you look at 9/4, yes, we cannot have a fraction in the radicand, but both the numerator and the denominator are perfect squares, so they can immediately come out of the radical house. And we know he's going to turn into an I, so our answer will be x is equal to positive or negative. The root 9/4 would be 3/2. So positive or negative 3/2I. And there would be the two solutions that would satisfy that quadratic equation. One more here for the square root method, number 5. It is a key one because it's going to be a quadratic equation. The way that it is formed, it's going to be the type of quadratic equation that we're going to be getting into when we move into method number 2 in 8.1, completing the square. It doesn't matter whether it is a monomial that's being squared or a binomial that's being squared, we still have a quadratic term here, and it's equal to the real number of 10. So we're going to find the square root on the left-hand side, and the square root of the x minus 3 squared would give us x minus 3, and that's going to be equal to positive or negative root 10. 10 does not contain any perfect square factors, and 10 is not a square. So we can't simplify that anymore. So all we'll need to do is move this negative 3 over to the other side, and we'll have our two solutions. X is equal to, changes sign when you move m over, 3 plus or minus root 10, and those would be the two solutions for that particular quadratic equation. Now that's the square root method. Now I'm going to erase, and we're going to make an entrance in to the second method of solving a quadratic equation, and that's utilizing the technique that's called completing the square. People, here is what is meant by this title. We're going to start off with number 1, which happens to be this equation, x squared plus 4x minus 1 is equal to 0. Notice it has all of the terms of the ax squared plus bx plus c is equal to 0. Now what we're going to do to this equation, we're going to turn this equation into a model that looks just like the very last problem that we did utilizing the square root method, where we had this particular situation, where we did this one. X minus 3 squared is equal to 10. We're going to turn this equation in to this form. It's called completing the square. You see, we have a square here. We don't have a perfect square here yet, but we're going to create one. And when this gets created, it's going to take on this particular form. Now there's a few steps that have to be done, and no, I did not write the steps down because I'm limited with time, so we're going to say the steps very carefully. And just remember, you can pause the video, you can stop it, you can rewatch, you can pause it. Here is the process of completing the square so we can get this equation to look like that form. Item number 1, I'll say it carefully and you can make this note. Item number 1, a key prerequisite. To complete the square, the coefficient of the quadratic term must be 1. The coefficient of the quadratic term must be 1. This coefficient is 1, so the prerequisite has been met. Now let's actually begin the process. Step number 1. We take the constant term of -1 and we move it over to the other side. And when we move it, we'll change its sign. So here's the activating of step 1. Bring down x squared, bring down the linear term, leave a space right here. It's going to be filled up in a moment. Leave a space because he's leaving. Move him over to the other side, change his sign. Okay. Now, the reason why this has been left empty, we are going to create a trinomial right here. And the trinomial that we're going to create is not just any trinomial, it is going to be a perfect square trinomial. And the perfect square trinomial that we're going to create here, when it gets factored, it's going to fall into this form right here. Not those terms necessarily, but this form. So here's how we create this very special trinomial. And I'll do it carefully. You take the coefficient of the linear term, of the x term. You take the coefficient and kind of pull it off to the side. You then take that coefficient of that linear term, which you kind of pulled off, and you divide it by 2, or you take half of it. We'll divide it by 2. That result, you put in parentheses. That result of dividing, put it in parentheses, and take it to the exponent of 2, always. Not because he's a 2, it's just taken and squared. So let me restate those. We move the constant term over to the other side. We take the coefficient of the linear term and divide it by 2. 4 divided by 2 is 2. It's important, put it in a house. Then we're going to square it. And that result that we get, which is 4, we're going to take that positive 4 and put it right here in this empty spot. Now here's a key move that some people will forget. We have just added a positive 4 to this left-hand side. The result of that action that we did over there. If we add 4 to the left, to keep this equation balanced, you've got to add 4 to the right. Now, this trinomial right here is not just any trinomial. It is a perfect square trinomial. And here's what its factor will be. You make a binomial house. Just like him. You bring down your variable term x. And here's how we get this second term. You don't have to look at this trinomial. You go right over here and look inside this house. He's a positive 2. Whatever is in that house, that member is going to finish off this binomial. So you take that positive 2 and put it here to the second power. The quantity of x plus 2 squared is the factorization of that trinomial. And it will equal 1 plus 4, 5. Look at this. And look at the one below my sheet of paper right there, which I think you can still see. They are the same structure. The same structure. Now we'll use the square root method. The square root of the x plus 2 squared, x plus 2 is equal to plus or minus root 5. 5 can't be simplified, so we'll move the 2 over and we'll get x is equal to negative 2 plus or minus root 5, and we have our solutions. Now I want to just do one more in this stage and then we'll call this video as it is. One more of completing the square. I'd like to show you 2 of them that are on this video right here so we see how it goes. Number 2, x squared minus 3x minus 2 is equal to 0. Completing the square. Step number 1, the prerequisite step. Make sure the coefficient of your quadratic term is 1. It's 1. We move into the process. Very first step. Take your constant term, move him to the other side. Leave a space. Move him over to the other side, change his sign. Next, go to the linear term and take the coefficient of the linear term, pull it off to the side, and we're going to divide it by 2. Or you can take half of negative 3. It's going to give you the same result. Now we can't literally divide that. Negative 3 divided by 2 does not divide evenly, so we're just going to leave it in that form. So after we're showing that negative 3, the coefficient of this linear, and we're dividing it by 2, tuck it and square it. Now let's square that negative 3 over 2, because the result of squaring negative 3 over 2 is going to fill this vacant area right here. Negative 3 squared is 9 over 2 squared, which is 4. So we've got a positive 9/4. We just added 9/4 to the left. We have to add 9/4 to the right. example, this trinomial right here, he on the surface looks so cumbersome to factor. But he's not. Because this that you're looking at right here that I've got in the parentheses, this is our help. This is going to be the second term of our binomial. So bring down the structure of a house. Put your X down first and go right off to the side of your paper and look inside your parenthesis. And what you see in the parenthesis is going to fulfill the remaining term of this binomial. Negative 3 over 2. Take it to the second, and it's going to be equal to the sum of those two. Now I do want to share. On this particular one, there's a bit of a shortcut that we can make use of. These two terms are both positive. If they were different, then I would definitively go through a common denominator. And I could still go through a common denominator here, but it isn't necessary. Because here's what you can think of this as. Even though there's a plus sign there, think of this as somewhat of a mixed number. 2 and 9/4. Why can I say that? Because individually they're both positive terms. So I can merge them together and call it primarily 2 and 9/4. Now what we're going to do is we're going to rewrite this 2 and 9 over 4 into an improper fraction. Multiply the 2 times the 4, that will give 8. 8 plus 9, 17 over 4. This is exactly what you would get if you drew a line below that 2 and put a 1 and renamed each one of those fractions with the common denominator. You get 17 over 4. We got it a little bit faster. Now, let's find the square root of the left, and that'll be x minus 3 over 2. And on the right, that will be equal to positive or negative root 17 over 4. I'm going to kind of erase up here. I'm going to bring up this x minus 3 over 2. And that's going to be equal to plus or minus. We're going to have to split this one up. We can't have a fraction underneath. 17 is not a perfect square, so we're going to have to split it up. And we'll have plus or minus the root 17 over the root 4. I could have just made that 2 right away, but I want to be complete here. Now I will. X minus 3 over 2 is equal to plus or minus root 17 over 2. Now we'll move that negative 3 over 2 over the other side, and we'll have x is equal to 3 over 2 plus or minus root 17 over 2. And look at those two fractional amounts that you see there. 3 over 2 plus or minus the root of 17 over 2. We can combine these two. The denominators happen to be the same. And we are going to combine them. We're going to write the sum of the two numerators, and we're going to put it over the common denominator of 2, and we'll have our answer. X is equal to 3 plus or minus root 17, the whole kit and caboodle, over 2. There's our given answer. Those would be our two solutions that we would have for that. Now, before we just sign off right here, in the next video, we'll be finishing off completing the square by looking at least a couple of examples where the coefficient of the quadratic term is not 1. And we'll show you how that works. And then we'll finish off 8.1 by taking a look at a couple of word problems that will make use of the square root method. Hold on to your horses right there, and we'll get back in touch with you in a few moments. Bye-bye.